Now in relation, I already discussed what is relation, properties of relations like reflexive, symmetric and transitive. In our relations, how can we represent relations by using 0-1 matrix? Today I will discuss how can we represent relations by using digraph. Digraph means directed graph. First definition of digraph. A directed graph or digraph consists of V of vertices. V stands for set of vertices, or you can say nodes, together with set E of ordered pair of elements of V called as edges, or you can say arcs. The vertex A called the initial vertex of the edge AB and B called the terminal vertex of this edge. Suppose we have a ordered pair like AB, then A will be one vertex, B will be another vertex, and we can add a edge, directed edge from A to B. A is the initial vertex and B is the terminal vertex. Suppose there is a ordered pair A, then we can add a self loop to itself. Let's see one example of digraph. A directed graph with vertex A, B, C, D. We have 4 vertex and edges AB, AD, BB, BD, CA, CB and DB. These are the ordered pair. Now there will be 4 vertex A, B, C, D, AB. So we'll add a edge from A to B, then AD, A to D, BB, it will be a self loop, then BD, then CA, add a edge from C to A, then C to B, then D to B. So this is the diagram. Next example 5. The directed graph of relation R. One relation is given on set 1, 2, 3, 4. So we have a set 1, 2, 3, 4. One relation is given and we need to create the diagram. Then first order pair is 1, 1. So there will be a self loop. Then 1, 3. There will be a directed edge from 1 to 3. Next 2, 1. Then 2, 3. Then 2, 4. Then 3, 1. 3, 2, 1. This one. Then 3, 2. Then 4, 1. Next example 6. What are the order pair in the relation R represented by the directed graph shown in the figure? We have a directed graph. This one is the directed graph, and from this we need to find the order pair. So first I will do for vertex 1, 1, 2, 3, 1, 2, 4. So you can write 1, 3, 1, 4. Next for 2, 2 to 1, 2 to 2 and 2 to 3. So 2, 1, 2, 2 and 2, 3. Next for vertex 3, 3 to 1, this one. Then 3 to 2, no edges. 3 to 3, there is a edge. So 3, 3. Next we will do for vertex 4, 4 to 1, 4 to 3. So the order pair are 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 3, 1, 3, 3, 4, 1 and 4, 3. We can also find properties from the directed graph. Means we can check whether it is reflexive, symmetric or transitive like 0-1 matrix. If there are self loop, then it is reflexive. If there are both way edge like A, B, there is a edge from A to B and B to A, we can say it is symmetric. Similarly, a relation is antisymmetric if and only if there are never two edges in opposite direction. Means if A to B there is a edge, then there is no edge from B to A. Next for transitive, suppose we have 3 vertex A, B, C. If there is a edge from A to B, B to C and A to C, then we can say this is transitive. Let's see one example. Example 10. Determine whether the relation for the directed graph shown in figure are reflexive, symmetric, antisymmetric and or transitive. We have 2 graphs. One is R, another is S. First I will check for R. In R there are 3 self loop, A to A, B to B, C to C. So you can say it is reflexive. And there are opposite edges B to C and C to B, not for A to B and A to C. So it is not symmetric and it is also not antisymmetric, as B to C there are opposite edges. So this relation R is reflexive, not symmetric, not antisymmetric. Whether it is transitive, A to B there is a relation, B to C there is a relation, but A to C no relation, no edges, hence it is not transitive. Next we'll check for S. S is not reflexive, as for A and C there are no self loop. So S is not reflexive. Now is it symmetric? A to B, B to A, then A to D, D to A to C, C to A. Yes, it is symmetric. Is it antisymmetric? No, it is not antisymmetric, as there are opposite edges. Is it transitive? Just mark C to A there is a edge, A to B there is a edge, but C to B there are no edge. So you can say it is not transitive. So the relation S is symmetric but not reflexive, not antisymmetric, not transitive, whereas relation R is reflexive, not symmetric, not antisymmetric, and not transitive. In today's lecture I discussed what is digraph, how we can use digraph to represent relations, and how we can check the properties like reflexive, symmetric, antisymmetric, and transitive. In next lecture I will discuss closure of relation. If this lecture is helpful for you, please like, share and subscribe. Thank you.